What theory is a major question in many academic disciplines. Let me offer you two perspectives what theory is and one perspective what theory is not. The first perspective is from the philosopher Karl Popper. He once said, theory is a net cast to catch what we call the world, to rationalize, to explain and to master it. So theories are abstract representations, simplifications of the real world, in which we try to capture essential elements of the world, of different aspects of the world, of IT systems, human relationships, natural phenomena, or whatever you like, capturing these different aspects in order to allow us humans to better understand the world, to better influence the world, to better anticipate what's going to happen in the future. This is one perspective on theories. Another perspective on theory is this one here. Well, at the core of theories, there are different factors. Now, these factors may be variables, constructs, concepts, or the like. Let's not be specific about that at the moment. Let's call them just factors A and B. But they're different entities. If you relate it back to what Popper said, then these are representations, abstract representations of things, phenomena, or whatever in the real world. So the first element of a theory is these different factors, variables, constructs, concepts, whatever. The second element is interrelationships, here depicted by this arrow. This might mean that factor A causally influences factor B. This can be other relationships between causal influence. It can be co-occurrences, covariances, or the like, process sequences. But any interrelations between the different factors. That's the second element of a theory. The third element is then the reason for this relationship. Why do we believe these statements about the interrelationships of the different factors to be true? That's the third element. And the fourth and final element is the boundary conditions posed upon the theory. So in which boundaries, where, when, and so on, is this interrelationship factor A causes factor B because of? Where is that valid? What's the scope of the theory? Or in other words, what is the boundary of the theory? These are the four elements which make a theory. The factors, the interrelationship between these factors, the reason for this interrelationship, and the boundary of the scope of the theory. David Watton, in an article in 1989, formulated this in four different questions. He said that the basic rules of scientific thinking are to think about the what, this relates to the factors which I just talked about, the how, the relationships among these factors, the why, the justifications, the reasons for these relationships, and the who, where, and when, as David Watton puts it, the boundary conditions. Now, if you think about judging whether a theory is good or not, then you can look at these different elements. You can look at the factors and you can see, is it comprehensive on the one hand side and parsimonious on the other hand? And achieving both is obviously a challenge, so there's a trade-off between comprehensiveness and parsimony. Looking at the interrelations between the different factors, you can ask, are these the key interrelations among all the factors included? You should have reasons, at least one reason, at least one justification for each of these interrelations. And the boundary should be as wide as possible so that the theory still holds, that it's still a valid description of the world. On the other hand, it should be narrow enough so that the theory can be specific rather than all-encompassing. So this was the second perspective on what theory is. Now let's turn to one perspective, what theory is not, provided by Sutton and Storr in 1995. Well, theory, according to them, is not references. If you look at academic papers, you see many references. You always have the list of references at the end. And in the text, you always have brackets with numbers in there or parentheses with names of authors and dates, like you see here on the bottom of the slide where I reference Sutton and Storr. Well, only references don't make a theory. Only recalling what others have said doesn't make a theory. You need to ground your theory in the earlier work of others diligently. You want to stand on the shoulders of giants. You want to adhere to the cumulative tradition of science and build on others. And you should acknowledge their intellectual elements in your work. So you should cite them, you should have references. Beyond that, you need to provide your own justification, which factors, concepts, constructs, variables, and the like you include in your theory, which interrelations among these factors you see, what your justification for these interrelations are, and what the boundary is. And that's not told by references, that's your theorizing building that up. The next thing Sutton and Storr position is that data is not theory. Theory explains why empirical patterns are observed. Theory explains why something in the world happens which we observe and which we capture in data. And data might provide support for theories. But data itself does not constitute theory. You need to develop causal arguments to explain why the findings are observed, and then these causal arguments relating to different factors and their interrelationships within the boundary, always going back to this perspective based on Wett in 1989, that is what makes a theory, not the data itself. The data is only there for providing support or refuting theories. The next thing which is not theory are listed variables and constructs. Lists of variables cover determinants, but they don't explain theory. You can have comparative tests of variables, but this is not a comparative test of a theory. And the key issue is why certain variables are more important than others. So it's about the selection of the different variables, and it's about the interrelations and the justification of the interrelations, not just having lists of variables, lists of constructs, long lists and tables. Like long tables with definition and lists are not theory, diagrams per se are not theory. Many theories are captured in diagrams, many research models are captured in diagrams, and frequently this is a good way of clearly, easily, and quickly communicating the core ideas in your theory. But the diagrams themselves are not theory. The boxes and arrows add order, but they rarely explain why they are there, so the justification is missing. And good theory is often representational and verbal, but the representation itself is not the theory. Finally, hypotheses and even predictions are not theory. A theoretical model is not simply a statement of hypothesis. Hypotheses are statements about what happens, not why it happens. So thinking back about the picture of the factors and the relationships, their justifications and the boundaries, hypotheses tell you something about the interrelation between different factors, but they don't tell you the reason. So hypotheses are statements about what, not why. And prediction without logic is not theory. The best performing prediction model based on new artificial intelligence, machine learning approaches and the like might be very good at prediction, but it's not a theory unless you understand the different factors enclosed, the justification of these interrelations, and the boundary conditions. So these are perspectives on what theory is and what theory is not.